Welcome to ICT Spot. So today our lesson is data structures and algorithms. So this is the first video of the data structures and algorithm playlist and hope you enjoy this. And this course is really designed for the beginners because I hope to cover most of the theoretical part regarding to these data structures and algorithms in this course module, and you can learn from the very basics to advanced level through this course. Okay, so let's start. So I have to tell you this at the beginning of this video. I'll do my best to help you clearly understand data structures, which are the basic building blocks for becoming a programmer in your journey. Then let's see what are the contents of our first lesson. So at the beginning, I hope to tell you what you should know uh, before the lesson. Okay, so if you know these few things, it will help you to better understand this course module. And also, then we are going to discuss what is an algorithm and what are the good qualities of a good algorithm. Then we hope to discuss about what is a data structure and data structures types. Then first let's discuss about what you should know to learn this lesson. So if you know C programming language, it's a plus point. So that will help you to keep this lesson much familiar with you. And if you know flowcharts and pseudocode, it will also help you to go with this lesson easily. Then our first main topic is what is an algorithm. Sometimes you may know about what is an algorithm means and sometimes you may not. So let's see what is an algorithm means. Actually, algorithm means a set of steps or instructions we have to follow to solve a problem or to do a task. Okay, it really means a set of steps to do a task. Think like this. When if we considering the incident of preparing a cup of tea, we have to follow some certain steps to preparing a cup of tea. Like we have to take a cup, then we have to put tea powder, then you have to boil the water, then you have to pour the water into the cup, then you have to steam this tea powder for few seconds, then you have to strain this tea powder, and then you can stir the tea with some sugar, then you can taste it. So it's kind of an algorithm because it's a set of steps that describe how to preparing a cup of tea. Similarly, algorithm is like this. Okay, it means a set of steps or instructions you can follow to solve a problem or to do a task. Here I have put a small example to clarify this idea. Think like this: how to put a cover on a book. Okay, first we have to cut the paper required to cover the book in a suitable size. Then you have to place the book on the paper. Then you have to fold the outer cover inward. Then you have to paste the inside close to the edge of the outer cover. Then you have to label your book in front for identification. So these are a few steps you can follow to put a cover on a book. Okay, so another one can write another steps. Okay, it might be fine. So this is a simple algorithm I can give you to put a cover on a book. Okay, so that's the special feature of this algorithm. Okay, different people can give you different solution, but all the solutions gives you the answer for your problem. Okay, we have to consider that regarding to algorithms. Then in ICT, it means regarding to our subject. Now we are talking about this algorithm a little bit advanced way. It means now we can consider this algorithm as a set of rules to obtain the expected output from the given input. It means similarly, what we discussed before, here we are discussing the algorithm as a set of rules to obtain expected output from the given input, not a random output. Okay, we are trying to take the exact output what we think at the beginning of the process. Okay, so that's the thing. We follow a set of rules to obtain the expected exact output from the given input. Let's see this chart actually. Okay, so here you can see input is there, then at the middle you can see a process, then you can see the output. So this process I have replaced by the phrase what you learned before as algorithm, which means the definition, a set of rules to obtain the expected output from the given input. Okay, so let's see an example. Okay, and I have to remember these two things again, which is uh, an algorithm can be demonstrated mainly in two ways. Okay, the first way is flowchart. It's a visual method. Okay, so you can implement your algorithm using symbols in a very clear manner. It means flowchart. It's a visual way of representing your algorithm. When it comes to pseudocode, it's a kind of a sketch using simple English terms. You can simply write your algorithm using simple English terms as a sketch. Okay, so these two methods you can use to represent your algorithm. Okay, then let's take an example. Consider this adding two numbers. Okay, the same diagram I have replaced with the suitable phrases. Let's see. Here the input is take two numbers as input from the user. Okay, so regarding to this incident, adding two numbers, we have to take two numbers from the user. Then here the algorithm is adding two numbers, or else I can call this as algorithm, or I can say this as rule. Okay, the rule is add the two numbers. Then output should be display the result. Display the result, which means that should display the sum or the total of the entered two numbers. Okay, then let's see. If we implement an algorithm for this problem, it might look like this. Here you can see start, enter num1, enter num2, sum equal sum1, number 1 plus number 2, then print sum and end. Okay, so this is the visual representation of our algorithm. if you like, you can write the pseudocode also. Okay. Then by using that algorithm here, I have implemented a code using C programming language. So here you can see it is very clear now because we followed that algorithm. So now we can clearly construct our code without any conflict. Okay, so you can see there are three variables I have taken at the initial stage as number 1, number 2 and sum. All are integers. Then it will display enter first number, then user will input the first number, then it will display enter second number, then user will input the second number, then it will follow a process as sum equal number 1 plus number 2. So then it will display the sum is, and the sum will appear to the user. Okay, so this is the simple code I have implemented using the previous algorithm. Then actually regarding to this algorithm, we are considering a quality. Okay, so what are the good qualities of a good algorithm? Let's see. Remember that all the inputs and outputs should be clearly defined in your algorithm. Okay, it should have clear inputs and clear outputs. Then each step in the algorithm should be clear. Okay, all the steps should be clear. Okay, don't write any complex things or complex statements or complex phrases in your algorithm. It not acceptable because your algorithm should be clear and much more simple, because that will help others to understand your algorithm very clearly. Okay, then algorithm should be effective in many different ways to solve a problem. It means your algorithm should be effective in when we regarding to different ways. Okay, so I will discuss this quality later as a topic. Then most importantly, your algorithm should not include computer code, because you know algorithm is a set of steps. Okay, that may be a flowchart or a pseudocode. We are implementing computer programming language codes by looking at the algorithm. Okay, so uh, different kind we can actually implement different programming language codes by looking at the same algorithm, which means we can implement different language codes by looking at the same flowchart or the pseudocode. Okay, so if you are implementing a Python code inside, I'm just talking about an example. Think if you are implementing a flowchart by adding a Python code inside there. Okay, then Java script, Java programmer does you think like that Java programmer doesn't know about Python. Then he might get confused. What is this? Okay, think there's a programmer who use C++. Then he also will confuse by looking at your flowchart because there's a Python programming code there. Okay, so that should not be acceptable in algorithm. Okay, so algorithm should not contain any computer code. Then instead algorithm should be written in such a way that it can be used in many programming languages. It's very important because we should have to build different types of computer codes in different languages by looking at your algorithm. Okay, which means the flowchart or the pseudocode. Okay, then your algorithm should be finite. That should not be infinite. Okay, it should be finite. Your algorithm should have a end. Then I told you I will discuss this quality as a topic. This is that algorithm should be effective in many different ways to solve a problem. Okay, so let's see this. Think like this. Here I have taken a very small example. Hope this will clear for you. Think that traveling from your home to your school. Here I have given you three options. First is walk, then take a bus, then ride a bike. You can select one option to travel from your home to school. Okay, let's see the benefits. If you walk, it's good if your school is nearby. Okay, if your school is very near to your home, walking is good. Okay, then take a bus. Take a bus is good if it's far or rainy. Okay, if your school is little bit far from your home, taking a bus is good. And if it's a rainy day, it's also better to take a bus from your home to school. Then let's see ride a bike. It's very good option because it's faster than walking and cheaper than bus. Okay, and the most important thing here is you can choose all these methods. Okay, you can follow any method to travel from your home to your school. Okay, it means all these methods are effective ways to travel from your home to school. Then, same as this, algorithm should be effective in many different ways. It means consider this. Sometimes here the most of the techniques we discussed, you doesn't know about these things. You may don't know those things. It's fine. You will learn these things in later stages. So here, suppose you want to sort a list of numbers in an ascending order. Think like that. You have some random numbers with different values. You have to sort these numbers in an ascending order. One person will say you can use bubble sort method. Okay. Then another person will tell you can use quick sort method. Then another person can tell you can use merge sort method. Okay. When you considering three methods, all are correct. See, if you use a bubble sort method, it's simple. It's really uh, capable to sort mostly for small for few numbers. Okay, few list, few element list. Okay, it's very because it's very slow when comparing to big list, but it's fine for small list. Then a quick sort is really good. It's very faster for big list. Then merge sort is really good for very large list or when combining data. Okay, so all these sorting techniques are correct. Okay, all these are different ways to solve the same problem, and a good algorithm can handle different situations efficiently. Okay, so that's the very important thing. A good algorithm can handle different situations efficiently. That should capable enough to handle different situation. That's the most important thing. Then what are the important facts we are going to highlight here? The first thing is it always, that means your algorithm always solve the problem correctly. That's the most important thing. Your algorithm should solve your problem correctly. Then your algorithm can adapt to different situations or inputs. Okay, it think like that. You are writing a formula to adding two numbers. it's your algorithm is really good to adding number 2 and number 4, but it doesn't work for number 11 and number 12. It's not acceptable. Okay, your algorithm should be adapt to different situations and different inputs. Okay, whatever the numbers we are input, we should return the correct total from these two numbers. Okay, that's what we are highlight here. Your algorithm should adapt to different situations and inputs. Then your algorithm can be implemented using different methods if needed. Okay, like bubble sort, quick sort, and merge sort. Okay, there may be different methods you can use. So your algorithm should be capable enough to implement using different methods. Okay, so methods you will learn at the later stages. Then let's see what is a data structure, the main key topic of this lesson. Okay, what is a data structure? Can we assume a computer today without data? Can't, no. Data is that much important for us today. Same as the data structures are also important because data structure is the way of organizing and storing the data inside our computer so that it is easy to use and access when needed. That means all the data inside your computer is actually organized according to these data structures. Okay, that's why you are really comfortably using your computer, because when you want to access 5 years back data, your machine will provide you with just like the yesterday. Okay, that's the secret. So data structures is a way of organizing and storing data in a computer so that it is easy to use and access when needed. Okay, now let's see what are the data structures types. Okay, remember that regarding to these data structures, mainly there are two types available. The first type is linear data structures and the second one is non-linear data structures. Let's see one by one. Linear data structure means just like a queue. Okay, here I have choose some pictures to clarify this idea. This linear data structure means it's arranged in a straight order, just like a queue. Okay, all the elements are arranged in a straight order, specific straight order. Okay, so see here you can see this tiger can eat this penguin. Assume like this. Okay, so this tiger cannot access the middle ones at the first. Okay, the tiger definitely has to access the first one first, then the next one, then third one, then fourth one, like that. Or else the tiger can access the last one first, then the next one, then the next one, and the next one, likewise. Okay. Then again consider the second example here. This penguin wants to access the this third cup. Assume like that. How he can access this? He cannot access the third one directly. Okay, he has to remove the first cup, then the second one, then he can access the third cup. Okay, that would be the approach. Okay, what is the key idea here? You can go through the elements one by one in a sequence. Okay, you have to go through the elements one by one. Okay, you have to keep that in mind in linear data structures. You have to go through the elements one by one. Here I have put some examples for data structures like this linear method. Arrays are example. Then linked list, it's a kind of a linear data structure type. Okay, remember that regarding to linear data structure, you cannot go through the random elements. Okay, you have to go through the elements one by one in a sequence. Okay, okay. Now let's see non-linear data structures, how it look like. Okay, non-linear data structures means a data structure is called non-linear if the elements are not in a straight line. Okay, if the elements are not in a straight line, it would be a non-linear data structure. So most probably it should have a look like a hierarchical order or a network relationship. Okay, so non-linear data structures are mostly look like hierarchical or network. Okay, here I have choose a picture of a family tree, so you can see these two parents has this parent has three children, okay, like this in a family tree, because one parent can have many children. Remember that relationship. Okay, one parent can have three children here. Okay, then regarding to the second example, here I have choose a picture of a network and a World Wide Web. Okay, so if you know the World Wide Web, you know all the devices what we are using are interconnected. Okay, interconnected. It not just to the next device in front of you. Okay, all the devices in the world are interconnected. Then consider a network. Similarly, all the devices are interconnected. What it means? It not just like the linear data structures. Okay, in linear data structures, we can connect only to the next element. But in non-linear data structures, we can connect to multiple elements. That's the plus point. Okay, we can connect to multiple elements regarding to nonlinear data structures. So here I have choose some examples as trees and graphs. Okay, these trees and graphs are good examples to clarify nonlinear data structures. Okay, you will learn these examples later. So thank you very much for joining with us. Until next time. So let's meet again with the second lesson of this lecture series.